Today we'll explore solving the differential equation y to the fourth power times y plus y double prime equals 0. This is a complex differential equation that requires careful analysis. Let's try to solve this using a common approach for differential equations. We'll assume that y equals e to the lambda x, which is a standard assumption when solving linear differential equations. Now let's find all the derivatives we need. The first derivative is lambda times e to the lambda x. The second derivative is lambda squared times e to the lambda x. And the fourth derivative is lambda to the fourth power times e to the lambda x. Let's substitute these expressions back into our original equation. We get lambda to the fourth power e to the lambda x times e to the lambda x plus lambda squared e to the lambda x equals 0. Now we can simplify this expression. The first term becomes lambda to the fourth power e to the 2 lambda x. Then we can factor out e to the lambda x from both terms. Since e to the lambda x is never 0, the other factor must be 0. This means lambda to the fourth power e to the lambda x plus lambda squared equals 0. However, we've reached a contradiction here. This equation can only be satisfied when lambda equals 0, which means our initial assumption of y equals e to the lambda x might not be the best approach for this differential equation. This tells us that solving this differential equation requires more sophisticated methods. We might need to consider numerical methods, specialized techniques, or additional information like boundary conditions to find a complete solution.